Okay guys, welcome to the next topic. So like before, basically I'll go through the PowerPoints that you have from the Teams page. You take down what is required, what I tell you to take down. You write it into your notes copies. Obviously pause the video when you're doing that and go back and rewind. If you have any questions guys, leave it in the comment section below or else ask it in the Teams page. Okay, so your heading here guys is energy. So that's the first thing you should be taking down is the heading, energy. Okay. Then, as always, your learning intentions. Now, this is going to be part one video, okay? So I'll try and keep it within 20 minutes. So, learning the intentions for this topic. So take all of these down. We have 1, 2, 3, 6. So we will be able to define what exactly is energy. We will know that energy has many different forms: kinetic, potential, light, heat, etc. We will know that the conservation of energy is how energy cannot be created or destroyed, but changed from one form to the next. Sustainable energy usage means the energy we use won't damage our environment. And we'll define power. Okay, that's not circling, but you get the idea. So we'll define power and state its equation. Okay, so define power and state its equation. There we go, we're back. And lastly, we will conduct experiments showing energy conversion. So I basically have 2 experiments in this that I'll go through with you, that how you convert chemical energy to electrical energy and heat, light energy to kinetic energy, basically, okay? So take down those 6 guys. You obviously pause the video when you do that. Today, we're going to be looking at, we will possibly get up to different forms of energy. So we'll get the first 3 done, okay? So we'll have define energy. We will look at what energy has many different forms. We will get that done. And conservation of energy, okay? And then the second video, we will look at sustainability, power, and then, of course, the experiments, okay? Right. So hopefully those taken down. Next heading guys is the keywords. So the next keywords that we're going to look at here today is, take all of these down. Work, what exactly does work mean? Power, what exactly does power mean? Energy, what exactly is energy? Okay, renewable, non-renewable, you probably heard those words before. Conservative and conservation, and sustainability. Now the thing with most of these words is you've probably heard them all before. You've probably heard work, power, energy, renewable, non-renewable, conservative, all of this, conservation. You've heard all of this, guys, but you've probably never actually questioned what exactly do they mean in a scientific context. Especially the big one, guys, is this word here, energy. Okay, so a lot of pseudoscience use the word energy for a lot of things like, I can feel the energy radiating off something, etc. Okay, so a lot of pseudoscience works in this idea of energy, and you can manipulate the energy waves and all that kind of things. You often see it. Recently there was something on Netflix with some guru, and his whole thing was that he could relieve your stress by manipulating the body's natural energy signatures. All nonsense, and that's what you're going to learn today about. That's why the importance of science, guys, is you can disprove all that kind of pseudoscience stuff. Okay, renewable, non-renewable, you most definitely know of that. Okay, and if you don't, well, shame on you, but we learn it now. Okay, you should know about renewable and non-renewable at this stage. It's all over the news, it's everywhere in the media. Conservation and sustainability, they're 2 things you probably heard before, but probably didn't look at it in a scientific context. Okay, so those are your keywords. Today's keywords, guys, that we will most definitely get to will be, of course, energy, and we'll get to renewable, conservation, we'll get to conservation, and yes, we'll get to renewable. Okay, so we'll get to renewable, but we won't get beyond that. So we'll get those 3 today, and then we'll do the others then on the second part of the video. Okay, all right. So first heading, guys, is simply just what is energy. So take that down. So what is energy? Energy, guys, there's 2 definitions really. It's is the ability to do work or is the ability to move something. Okay, so energy is basically, there's many different forms of energy. Heat, for example, is a form of energy. Why is heat a form of energy? Because it can make things move. Okay, energy is the ability to do work or to move something. Okay, you can move something a certain distance. Okay, you can move something to get up the stairs, to get out of bed in the morning. You need energy to get up and out of bed. That's why you often, if you're tired, you feel, oh God, I don't have the energy. Okay, what you're actually saying is you don't actually have the physical energy to move something. Okay, so energy, guys, is the ability to move something. Okay, so everybody has energy. Yes, we have energy, hence why we have body heat. Okay, so the body heat you're giving off, the heat you're giving off is actually a form of energy. And the reason you're giving off heat is because your body is actually moving. Your lungs are moving, your heart is beating, your kidneys are working, your liver is working, your digestive tract is working. So even though you're just sitting down, okay, your entire body is still actually running and it's still actually doing things, okay? So that's why you're burning off, that's why you've got body heat, is your body's still burning the calories, releasing that energy, okay? Energy is the ability to do work or move something, okay? Now, no outside force can manipulate your energy signatures by waving their hands over you or putting magnets on your body. None of that works, guys, okay? So putting a magnet on your body isn't going to manipulate your energy signatures and make you do something, okay? Energy is just the ability to do work or move something, okay? Now, the next key thing is how do we measure it? The SI unit is the joule, okay? Capital J, okay? So the joule, capital J. That's very important, it's the joule. Now, a very important thing is energy equals energy, okay? So all energy is equal to each other. Energy equals energy. Now, that's not hugely important for now, okay? But if you go on to do leaving cert physics, that plays a big role in a lot of calculations, okay? Kinetic energy equals kinetic energy equals potential energy equals heat energy, etc., etc., etc. In other words, if the maximum potential energy you have is equal to the maximum kinetic energy you have, okay? Which is equal to the max heat produced, all right? But it's a bit more above your pay scale at the moment, okay? So take that down. Energy is the ability to do work, or energy is the ability to move something, and energy is measured in joules. All right, so the next slide, what are our forms of energy? So that's your heading, guys, forms of energy. So there are two, okay? So we have two forms of energy here. The first one is potential energy, okay? So the first key one here is potential energy, okay? So energy that an object has due to its position or shape. Okay, all right, so that's kind of the key, or the energy that can do work when released. So basically what we mean by that is that you can do it here now at home, actually. If you have, say, a book there next to you, okay? If you hold a book at waist height and then drop it onto the floor, okay? There's a bit of a bang. Now if you hold the book at your head height and drop it, you'd hear a louder bang. Okay. Now the reason for that is that when you held the book at your waist, it has the potential to release that energy as sound. Okay, when it hits the ground. Okay. The reason the sound and the bang is louder when you held the book higher up is because it has more potential energy. Okay. So where you are, your position will determine the amount of energy that you have. So for example, if you're in another example would be, let's say you're on a bike and you're going to cycle down a hill. Well, if you're at the top of the hill and you start going down, you're going to go faster than if you, say, went halfway up the hill and decided that's high enough, turned around and went back down, okay? So the energy is the ability to do work due to your position, okay? And generally for us, it's basically where you are. So in other words, the higher up you are, the more energy you're going to have flying back down on the bike, or with a book, if you knock a book off the table, it'll make a bang, but if you held the book up very high and dropped it, it'll make a louder bang, okay? So energy that an object has due to its position. The second thing is the easier one for people to get kind of comprehend is kinetic energy. Now, kinetic energy is the energy an object has when moving. Okay, so if you are moving, you have kinetic energy. Okay, so when you get up out of bed, that's kinetic energy that you're doing. When you're lying in bed, you have potential energy. You see, so this morning when you were in bed, that was potential energy. You had the potential to get up and move. When you got up, you then moved into kinetic energy. Okay, so everything that's moving has kinetic energy, okay, and everything that's staying still has potential energy, okay, generally, rule of thumb, okay. It's a little bit more complicated than that, but for juniors or guys, that'll get you by, okay. So kinetic energy, if something is moving, it has kinetic energy, and when something is kind of in position, waiting to move, it's got potential. It has the potential to move, and kinetic, it is moving, okay. So take down those 2 points there, guys, and then if you have a chance, with the video, you can watch that. That's a small little animation showing you the potential and kinetic energies. It's a skateboarder and you create the ramps and he goes up and down the ramps, okay? So you can have a look at that actually after. It's a fun little animation. Okay, so we're going to look at the forms of potential energy now, okay? So our forms of potential energy. I have two here. There are many, guys. There are countless, but these are just the two I came up with. If you have any others, by all means, ask if they're acceptable. Most likely they are. But the two key ones that we use are nuclear energy, okay? These are the two, because it is the energy stored in the atoms, okay? So basically what nuclear energy is, guys, is we split an atom, okay? We split an atom, and this releases huge amounts of energy, okay? That's called fission. Then what we're looking to do is if we could create fusion, because if you create fusion, is you merge atoms, okay? And that could create a huge amount of energy too. Fusion is what's happening in the sun. And basically if we can copy that, then we'd have a limited energy source. Let me see, we're halfway. and the 10-minute markets, okay? Now the second point I want you to take down is chemical energy. Okay, so what is chemical energy? It is the energy stored in chemicals like petrol, coal, and food. That's key. That's what petrol is. That's chemical energy. Okay, so when you put that into the car, and then, well, you don't, but when it's put into a car and you turn the key, you ignite and you turn that chemical into heat energy. That heat energy then goes and moves the parts of the car. Okay, so that's kind of what it is. Okay, so it's potential nuclear and chemical. All right. Okay, so the next thing to take down, guys, forms of kinetic. So I have 4 here. Let me see. I'll tell you what, I'm going to go through all 4. You pick maybe 2 that you prefer and go with that. Okay, so you only need to pick 2 here. I don't mind which 2 you pick. I'll go through all 4. Just an idea that they all mean kinetic. Okay, heat is a form of energy because it makes things move. Okay, so heat is a form of energy because it makes things move. Okay, light energy. So now what we mean by that is solar panels, for example. If they have solar panel cars, solar panel planes, what they do is the electricity hits them and they generate that into kinetic energy. Okay, but actually, do you know what? I'd leave that one out. Don't put in that one. I'd avoid that one. Okay, this is the key one. This is a good one that nobody really thinks of. The light one, guys. The reason I'm saying leave that out is now that I'm looking at it, it doesn't. I understand what I'm trying to say there, but in the examiner might not grasp what you're trying to say is we're converting the light energy into kinetic energy. So just leave it out. Sound energy. Okay, sound energy. Sound makes things vibrate. So the reason you can hear things is because of the vibrations in your eardrum. That's exactly what sound is. Okay, sound is basically the wind from your lungs, the air from the lungs passing through bits of muscle in your throat, and that muscle is the voice box, and that's making squeaks and grunts. And those squeaks and grunts we interpret as sound and speech and language. And that's where we're getting sound from, that vibration through the air. Okay, so the reason you're able to talk is you're actually sending vibrations through the air that we pick up in our ears. Okay, and then of course, electrical energy moves in the wires. It's electrons passing through the wires, and then of course we use it in our everyday lives. Okay, so there's 3 there. Pick one of the 3. They're all kind of the same, really. Kinetic, guys, anything moving. So if you're ever asked for kinetic energy, which object, usually what they'll do, guys, is they'll give you scenarios, which one of these is kinetic, which one of these is potential. And if it's moving, it's kinetic. That's a general rule of thumb. Okay, so pick 2 of the 3 there. I don't mind which 2 of the 3. Okay. Let me see, what are we on? All right, okay, so I was hoping to get down to slide 16. We might not do it in this video, but that's okay. Okay, so you're heading here, guys. This might be a 3-part topic. Conservation of energy. Okay? Take down that heading. So this is a very important idea and an important concept. Okay? So when energy changes from one form to another, this is known as energy conversion or an energy transfer. Okay? What I want you to note here, energy does not get used up. It just gets converted into another form. Energy can't be magically created. Okay, there's no magic where you just out of nowhere you have energy. Okay, and you can't get rid of energy. Energy doesn't disappear. It simply transforms into another form. Okay, so the energy we have is recycled on the planet. Okay, and all the energy we get comes from the sun. That's our main source of energy. If the sun didn't exist, life wouldn't exist. Okay, all right. So the sun is literally all life on this planet. Okay, the food you eat to the plants that grow, it's all from the sun. Okay, even the driving your car, that energy originally came from the sun. Okay, because that's made from petrol, which is fossilized animals which survived for years off eating plants which got their energy from the sun. Okay, so the sun is basically our primary source. Okay, so energy doesn't get used up. Okay, so basically what is happening to this energy? Well, you turn on the light switch, that's electricity gets turned into light and heat, and that heat gets released into the house. You see? And then that heat then, of course, changes into something else. And the electricity that doesn't get stays as light, that gets bounced and reflected and etc. Okay, so the energy just keeps changing. Okay? It doesn't get used up. It changes. Okay? So what's our definition then? Same heading. This is our definition. Okay? Take this down, put it in red, it's a key definition. The conservation of energy states that energy cannot be created or destroyed. Energy cannot be created or destroyed, but can only be converted from one form to another. Converted from one form to another. Okay, so you cannot create or destroy energy. You can simply convert it. Okay, we convert from one thing into another thing. Okay, that's an important key thing to remember, guys. That's a key definition that you need to know. Okay, now, interesting question here. Can you explain why the amount of energy into a light bulb is less than the amount of energy that comes out? Any ideas? I kind of half gave it away a second ago. Well, the reason is, guys, is there's no such thing as a perfect machine, okay? In other words, that when you put electricity into something, 100% of the electricity will not be used in just doing the function. So, for example, light bulbs, their function is to give us light. But 100% of the electricity is not converted into light. Some of it is converted into heat. So that's why. So the energy that comes out is less because some of the light, some of the electricity, some of the energy is turned into heat, not light. You see, that's why the new bulbs, the energy efficient bulbs, they're called energy efficient because the old wired bulbs used to give off a huge amount of heat. So I think it was something crazy like 40% of the electricity was heat, whereas now it's something small like 5 to 10% of the electricity is heat. So it's a massive drop down. So you save electricity that way. So now there's less electricity going in to give you the light. Okay, that's why. Again, there's another nice little video there. I'd advise you to maybe watch it at the end of this video. Go back and watch that video. Okay. And here you have our conversion of energy, as you can see here. See here, you have your nuclear. Oops. Get rid of that, sorry. So our nuclear here, okay? And nuclear is attached, it gives off, see the way nuclear goes to heat, it goes to electricity, it goes to sound, it goes to kinetic. So it's a link, okay? And everything is kind of linked there, you see, because light is, of course, nuclear as well, the sun. And the light is giving it off to, where are we? Chemical, and it's also going down to electrical. Heat is bounced off to a few things. So they're all interconnected. That's kind of the idea here, is that it's all interconnected. All the energy is interconnected. Okay? Chemical energy goes to potential energy, goes to kinetic, goes to sound, goes to electrical, goes to heat, goes to light. Okay? And then back. Okay? So they're all interconnected. These are all different types of energy. You don't need to write that in. Okay. What about? We're on 17. Okay, so I'll do the next two slides and then we'll probably leave it at that. Okay, so what you have here, guys, take down this heading. Experiment. Chemical energy to electrical energy to heat energy. Okay, so that's your experiment. Chemical energy to electrical energy to heat energy. Okay, so just take that down. Okay, now I have here this little diagram here. Okay, so there's a little diagram here, picture. So what we're doing here, guys, is you have your battery. That's the chemical energy, gets converted to electrical, which is in the wires, and then it turns into heat when it hits the bulb. So there you go. Now, how do you draw that? I want you to draw that in, but I'll show you how to draw that. And new slide. So how you draw that is you just draw this, okay? Just draw your square, label that as a battery. And then have your wire go down like this, and that's the symbol for a bulb. Okay, so you have your battery. Now we should draw the chemical symbol for a battery, but it's fine. We just draw it this way, be easier for you, to your bulb. Okay, and that's it. You just then explain that when you connect the battery, the bulb will light, thus giving off heat, and that's it. Okay, so draw in that diagram as well. So that's your heading, that's your diagram. Okay, so I'll remove that. Delete that. Okay, so now second experiment that I have you do today is light energy to electrical energy to kinetic energy. Okay, now you won't really be asked to draw this one because it's a bit too awkward really, but all you need to remember is just right after this, solar powered car. Okay, so that should probably remind you. So if you're asked, do an experiment to show that light energy is converted into electrical energy into kinetic, just remember solar powered car, and then all you got to say is have a solar powered car, shine the light on it, the car moves, done. That's it. Okay. All right, so we'll leave it at that. Now I know in class I demonstrate these two, but obviously we're not in class, so we got to do what we can. So when we get back, I might remember that. Okay, so we'll have to leave it there, guys, because we're at the 20-minute mark, and with you pausing the video and writing, it's probably hitting close to the 40 minutes. So let's look back at our learning intentions. So what did we get? Define energy, know the difference, many forms, and conservation of energy. So we got 3 done. That's not bad. Okay. Look at our keywords, energy and conservation. So we've a lot of keywords yet to get to, but we've got a few of the learning intentions done. Okay. So we will leave it there, guys. We leave it at that. That's the end of part 1, and I'll put up part 2 then pretty soon. Okay. All the best.